So Jiva, we're going to move now to a technology that is iOS and OS 10, as opposed to just OS 10 for garbage collection. Quite a new technology to this platform anyway, called blocks. So what are they?
Well, blocks are one of the new additions to Objective-C. They were just introduced in Objective-C 2.1. So therefore, they're only available on Snow Leopard. They're also brand new to iOS. They're only available on iOS 4, although there were actually some third-party libraries that you could use to get blocks on earlier versions of iOS, but they weren't an officially supported part of the iPhone SDK. And essentially, if you've come to Objective-C from some of these other platforms like Ruby or Lisp, you may already be familiar with the concept of closures or blocks. And basically, a block or a closure enables you to define a function and treat it as an object. You can define this function right in line in your code and treat it just like any other variable, which means that you can take this function object and pass it off to other methods or to APIs that expect a function of that type, something that takes this kind of a parameter and returns this kind of value. So that's really a very powerful concept when you think about it, because what that means is that you can define these reusable behaviors that you can then either, you can pass them around, or you can swap them out, you can interchange them with each other with different behaviors at runtime, and it enables you to write APIs that are incredibly flexible. You might, some of the ones that are available in Cocoa itself or in the Foundation framework have to do with NS arrays and things like that. You can pass one of these function objects to an NS array, and then the NS array will then iterate over all of the elements of the NS array using that block that you've passed in to do something to each one of those elements. Really cool technology, really powerful technology. So let's take a look at how we actually define a block and how you use it. So first we have this code here, this example code, where essentially to define a block, it works a lot like if you are defining a variable. You have to first set the type, okay? Now in this particular case, the type of the block that's specified here is actually going to be the type of value that's returned from the function that you define inside of the block. So in this case, we're actually saying that we're defining this as a void block, which means that this particular the code that is the body of the block won't return anything. It'll just do nothing. Then, and this is very important here, you have this kind of special syntax here with this caret here. You're giving the name of the block here. This is going to be the actual name of the block variable, and then this caret here is what actually says I'm defining a block.
So like the star says it was a pointer, the caret says this is a block.
Exactly. If you're familiar with defining like function pointers and things like that, this kind of syntax is very, very similar to that. Then now most variables, when you define them, you don't have to worry about things like, parameters to those variables and stuff like that, right? So if we were just defining a variable here, if we were declaring a variable, we'd be done. We'd just have a semicolon. But of course, with a block, you actually have to specify the parameters, the argument list that will be passed to that block when it's actually executed. Mm-hmm. Just like you have to specify the parameters that are passed to a function when you when you define a function, right? Mm-hmm. So that's the next thing that you include in your block declaration. So this is right here. This is a block declaration, just like declaring a variable. Now we haven't actually assigned a block to this variable yet. We've just said, just like if we were declaring a variable. Let's say we had something like int x. Okay. That's exactly the same thing that we've got here. We're just saying void my block takes as a parameter in this case an NS string object.
Fine, okay, let me make sure. So we declared a block called my block, which is going to hold a block that takes a single parameter of an NS string.
Correct.
Okay.
And if we
I
wanted
think
to,
I just repeated exactly what you said there, but it helps me make sure I understand it.
repetition is good. Now, and just like if you were defining a function, you could also add another parameter on here. You know, if I wanted to add, you know, an int y parameter onto the end of this, I could add a comma and define that parameter as well.
So it's worth, I guess, noting here that we're defining these parameters in a C function style as opposed to the named parameter Objective-C style that we've been using for object methods.
Yes, that's correct. So now to actually assign the code block object to the variable that we've created, you can then use your object after you've declared it like this, right? You can then use your block object just like a variable. So now I've got this my block object, and I can assign things to it using the equals operator, just like if I had a variable. So here we're actually doing this my block equals. Now again, because we're dealing with blocks, we have to have a little bit of a special syntax in that you will have this caret syntax here, and then your argument list. Now, if you don't have an argument list, you actually just can leave that out altogether. And then you have the curly braces that indicate the body of the function that you're defining to be the block object.
Okay.
So here we've actually just created a block function that takes as a parameter, okay, here's our block variable. It takes as a parameter an NS string. That parameter will be called X, and it will be available inside of our block, just like if we were using a function. Then we have the actual function body itself of the block, and inside there, we're actually using X to just print it out using an NSLog. Now, you know, we've talked about how programmers tend to argue about indentation and curly brace locations and all kinds of things like that, right? In this particular example here, I've shown it where you've got, you know, the curly brace after on the next line and things like that. A lot of times, a lot of developers like to do it where they'll put the curly brace up here. It all means exactly the same. So even if you've got it here, if you've got it up there, it's all perfectly legal. Sometimes it even looks a little bit cleaner, I'll admit, to have the curly brace up on the other line for the block declaration. But
we could even shift that whole thing onto one line if we wanted to.
you absolutely could. And we'll see some examples in just a minute of exactly that.
So basically that's saying from the equal sign, after the caret, everything inside of those curly braces is the function code that's going to be part of this block.
Yes.
And then the whole statement, unusually we see then a semicolon at the end of it because we need a statement terminator to define the end of the thing.
Yes, exactly. So let's take a look at some more examples. So, you know, we were just talking about, this is basically the code that we were just looking at there, that function block there. Here's another example of basically doing it in line. You know, we've got another block here. This takes a string parameter. Basically the same thing, but just doing it all in line. And that should actually be an at. So exactly what we were just talking about, that you could just do it all in line. Now, you remember I mentioned that if you have a block that takes no parameters, then you could actually include the just empty parentheses after the variable name declaration. And then if you notice, there's a subtle difference here with the actual function block, or the block itself where you're defining that block, in that we have the caret and then it goes right to the curly brace there. There's no parameters shown there, unlike up here where we have the parameter shown there. Because we don't have any parameters here, it can just be omitted. That's perfectly fine.
Okay.
Then as far as how you actually use it, when you're actually using these things, you can pass in the variable. For example, if I stored this into, well, if I use this right here, right, I've got this a void block here, right? And I could just to actually use it, let's say I had this do it function, I could just say do it and then a void block. That would be perfectly valid to actually pass this block to another function that will then be using this block.
Right, okay. So that's not actually running the block, that's just passing the block.
Correct. It's just passing the block
It's
to
just a
that other-
variable still at this
It's just a
point.
variable. Then inside of that function would then have to do some things, which we'll see momentarily, to actually execute the block and get its return value and stuff like
So
that.
at this stage, all we've done is we've defined blocks, we've put code into the blocks, but we've not run anything. None of this is running it. This is just now a variable we're passing around.
Exactly. But the reason I wanted to point that out is because another important aspect of blocks is that you actually can even define them right in line when you're going to call one of these methods. So if we had this doIt function, for example, that took a block as a parameter, you don't have to, just like you don't have to necessarily declare a variable that you're going to pass to it. You can just pass the value. You can also pass the code block itself, the block that you are that you would be assigning to the value, and that's what we're doing here. Essentially, we've eliminated the variable that we were assigning this block to, and instead we're just passing the block body right into this function, and that's perfectly legal. You can do that just like if you had a value that you were passing in.
Okay.
Okay. So now, in terms of actually using the code block in a function that uses a code block, essentially you have to declare your function to use a code block, and you do that again by using that same kind of syntax that you use when you're declaring the code, the block variable. In this particular case, we have this function called function which uses a code block, and it's taking as a parameter a block that has an NS comparison result as its return value. So this block is expected to return an NS comparison result. It's going to be called the block. That's going to be the variable name that the block will be stored inside of our function when we actually go to use the block.
Right, so that's how we'll refer to it inside this function, yeah?
Exactly. And again, remember, we've got that caret in front of it that indicates, just like when you're defining a pointer that you're passing in, you've got this caret in front of it, just like if you had a pointer with an asterisk there. Then again, the argument list, just like we did when we declared our variable.
Effectively we were repeating the declaration.
Exactly, just repeating the declaration.
So but to make this clear, this is effectively a variable declaration again.
Yes.
Within here. So the bit that says the block naming it doesn't have to be called that when we're creating a block elsewhere to pass in. That is just a variable name.
Correct. It's just a variable name, and that's just what the variable will be named when we use it inside of the function that's using this block.
So just like we could have a function that received an integer and we called the parameter x, and then we could pass an integer somewhere else we've called y into it, it's exactly the same principle.
Exactly.
Okay.
So now here's the same function kind of expanded out a little bit. So we've still got that same function signature there. And then to actually use the block itself, you just use it like any other function. So in this case, again, we passed in the block variable, which contains a block that returns an NS comparison result and takes as a parameter an NS string. And then down here in our code, we're actually just calling, right here, the block, and we're passing at, quote, foo as the parameter to that block.
Which is an Objective-C string syntax, which we still haven't dealt with, but we will do.
So it's just a function. That's all it is. Very simple to use. It's just as ugly and icky as the function as the block definition is. It's beautiful and elegant when you're actually using it.
It basically means we can have functions that have static code. But equally pass some variable code, depending on circumstances, into them as well.
Yes, absolutely. So, and in this, the rest of this particular function is just saying, if the return value is NS ordered same, which is one of the options for NS comparison result, then do same, and else do else. So, the rest of this is really just sort of boilerplate example code. But you get the idea that, this is how you actually execute these function blocks. Now, when you are using a block with an object method or a class method, the syntax is slightly different in that you're not specifying the name of the variable that will be used inside your method body right after the caret. Remember up here, right, we had the block variable name right after the caret, right there in the definition. Of course, that doesn't really match up with Objective-C method naming. If you did that, you would actually wind up having the variable name right there, right after the caret. So instead, when you're using them with an Objective-C method, you actually just omit the name of the variable there and instead put it at the end of the argument, just like if it was a passed-in argument of any other kind. So very straightforward. As far as how you actually use it, you're still using it exactly the same way here. You're basically using it as a function inside of your method.
Yeah, it's a shame they have to be different, but I guess we learn to live with that.
Just the way it is, unfortunately.
Nothing we can do about it, so
yeah.
Move on.
Now, there's some special scoping rules that are used when it comes to blocks, in that one of the cool things about blocks is that when the block is defined, so in other words, when you actually assign a block body to a block variable, the block itself gets a copy of all of your stack variables, including self and everything else, as part of its environment. Now, all of these variables are read-only, okay? So you can access them, but you can't write to them. You can read from them, but you can't write to them.
Okay.
Right? So in other words, looking at this code here we've got this NS string format string, right? Which is just it's just a variable that's in our current stack in this particular little program here, right? When we actually declare this block right here, we're actually able, even though we haven't passed in any format string variable here, that's not part of our argument list, we have access to the format string from our stack.
Right.
And it gets copied into the address space of the block itself. So in other words, when we go to actually call doit here, we're passing this off to another function, it will also get that format string. So that's another really, really powerful capability that that these blocks have. So in other words, you get it into doit, and doit has not just the format string, but maybe doit has an array of strings that it's going to pass to the block as it's iterating over them to print something out, right? So this gives you the ability to kind of slip in a format string and have it iterate over all of the elements and substitute in each of the elements into those into the output as it prints out.
That's very powerful.
It's incredibly powerful, but it gets even better.
Okay.
So now again, one of the caveats of that is that all of those runtime variables that you have access to there are read-only. You can't write to them. Mm-hmm. But there is a special keyword called __ block, which allows you to specify that a particular variable in the current stack will be available in a read-write form to any blocks that use it.
Okay.
So in other words, in this particular case, right, we're defining this my string. We're assigning a value of dead beef, and we're defining it with this __ block keyword in front of it. And so what that actually winds up doing is it takes this variable, which would normally just be something that was read-only, and it actually copies it into the heap, and it will make that variable available to be written to inside of our block. So now when we define this block down here, okay, we are actually able to take my string again, right? My string's up here. We take my string, and we're able to append another string to it. So like decaf bad, right?
Yep.
These are just strings that we're just putting in there, right? But the point is, we are able to then, that string becomes mutable. Now, there is a little bit of a caveat here also in that the underbar block modifier, while it makes the object mutable, it doesn't make it so that you can assign to that pointer. So in other words, I couldn't just say new string to my string.
I can only manipulate what's already in the pointer.
I can only manipulate objects, mutable objects that are already there.
Okay. And we'll deal with mutable, non-mutable strings and everything when we get there, yeah.
So essentially, so in this case, if I do this and then I pass it off to do it, my block, and then it executes that block, and then later on I come back and I print out my string, then it will actually print out dead beef and decaf bad together.
And because it's an object, it's the same one, so yeah, that all works. Yeah. Great.
Now, as far as other memory management is concerned, blocks handle most of it for you. And of course, if you're using garbage collection, then you don't have to worry about memory management at all. But in terms of, I shouldn't say it handles most of it for you because it doesn't do retain and release and things like that. But the point is that the normal memory management rules apply.
Yeah. Okay.
Right. So in other words, if you define a block that takes a string and you want to keep it around or something like that, well, if you want to retain and release blocks, of course, you can treat them just like regular objects. So if you have, in this particular case, right, we have a member variable that is a block, and we're passing in a block to this method here, and we want to keep that block around. As we're going to assign it to our memory variable, then we need to retain that guy, and we need to also, therefore, remember to release that block later on when we deallocate. So now, we looked at, early on, we looked at the different examples of block syntax. And as you can see, in a lot of ways, you look at some of this stuff and you go, wow, that's some chicken scratch there. You got all these, these carets and parentheses and curly braces and, wow, that gets pretty ugly pretty fast. And in particular, when you start looking at passing these around to multiple methods, or if you wind up with an argument list that's very big to one of these blocks, right, it gets pretty ugly pretty fast. So, fortunately, we can use our old friend that we worked with when we were looking at structures, typedef, to make handling the blocks a lot cleaner. And
okay.
Most of the time, when you're working with structures, when you're working with blocks, you probably want to use typedef to make them look a little bit better. So let's take a quick look at an example of that. So in this case, this is actually the same class that I was showing just a minute ago with the memory management. It's a class foo that takes a myblock, or it's got a myblock member variable, and that guy takes an NS string pointer. But in this case, I've actually I've typedefed the block declaration, so that I've got this variable called, or this type definition called block with char arg. That should probably be block with string arg.
But that's a lot neater, isn't it?
It is. Now, if you look down here in my actual class definition, all I have to do is just do block with char arg and my variable name, and I can do the same thing with my method names as well, or with my method declarations as well. So right there, it's so much cleaner. It looks like just any other method declaration, right?
Yeah, that's more readable. It's nice. Obviously, you've got to try and remember what block with char arg is, but it's at the top. It's easy to read.
Right, exactly. So, so definitely, when you get in there and you start using blocks, definitely use typedefs whenever possible to kind of make your code more readable. Again, it comes back to that thing. You're writing for that guy 6 months down the road, including yourself. So, so that's pretty much how you declare and use blocks. Now, the foundation frameworks, when we look at NSArray, we'll see that there's a whole bunch of places inside of Foundation that actually use blocks right now, that provide APIs that allow you to pass a block to them and then do all kinds of nifty stuff inside the Foundation frameworks. But we'll really deal with that more when we talk about collections.
So that's like we created a class just now that had a method that took a block as a parameter. Equally on a lot of the Foundation classes, they've done the same thing.
Yes.
We need to understand blocks to do it, but we'll look at what those methods do when we get to those classes.
Yes.
Great. So that's it. So what are we going to do next?
Next is protocols.
Protocols.
Which is cool stuff.
I'll take your word for it. We'll have a look in a minute.
Bye.